Alice Sue, and today we will be discussing the drug Lyrica, whose active ingredient is pregabalin.
Okay, so the body interprets pain in a simple neural pathway. Normal pain is nociceptive pain, which is pain from physical damage or potential damage to your body. Neurons fire an action potential as a result of stimuli. When your body experiences pain due to trauma or inflammation, signals travel through your peripheral nervous system, which includes your joints, to your central nervous system, and that includes the spine and the brain. Once these systems reach your brain, they are processed and sent back to the peripheral nervous system to help modulate the pain. As your body is no longer experiencing pain, fewer neurotransmitters are fired, and the network along the pain pathway calms down. However, unlike nociceptive pain, some pain in the body does not subside because of damaged neurons, and that is what is referred to as neuropathic pain or hypersensitive neurons. Lyrica is a drug approved by the FDA to treat certain neuropathic pain, like pain after shingles, spinal cord injury, and chronic hypersensitivity. Lyrica can reduce your body's ability to feel pain. Pain happens as a result of complications such as diabetes, and over time, diabetes leads to high blood pressure. High blood sugar levels can damage nerves, and you need your nerves to help your body move, communicate, breathe, and so much more.
What is Lyrica? Lyrica is a gamma-aminobutyric acid, also known as GABA, with an isobutyl substituent on the beta position. GABA is known for producing calming effects and lessens the ability of nerve cells to receive, create, or send chemical messages to other nerve cells. Lyrica is used as an anticonvulsant and calcium channel blocker. Lyrica inhibitor of neuronal activity and mirrors the effects of GABA by calming overactive nerves and helping treat pain from nerve damage. Even though Lyrica has a similar structure to GABA, it does not bind to the GABA receptors. Instead, Lyrica binds to the alpha-2 delta subunit of the synaptic voltage-gated calcium channel in the central nervous system.
Let's talk about the mode of action of Lyrica. Lyrica works by binding to the alpha-2 delta subunit of calcium channels on neurons. When Lyrica binds to the calcium channels on hyperexcited neurons, it modulates the influx of calcium ions in the presence of frequent action potentials. This causes fewer calcium ions to enter the neuron, which means fewer transmitters will stimulate the next neuron, which will cause the network of hyperexcited neurons to return to a calmer state.
There are many pathways to synthesize the pregabalin generic form of Lyrica. The literature we chose from synthesized Lyrica in the following way. The final product comes from a reduction of the nitro compound in step D, which was synthesized by a single displacement substitution reaction in step C, and that comes from a Michael addition in step B, which was synthesized in a Novengel condensation, which ultimately started with a commercially bought compound. The following was the retrosynthesis. Now we are going to talk about the 4 steps of the forward reaction.
The first step to synthesizing Lyrica is to start with a commercially purchased 5-methylhex-2-enoic acid. It will react in a 2-step process. The first reagent is oxalyl chloride in DCM, and the second step is to add DMAP and oxazolidinone. This chiral auxiliary reaction is naturally stereoselective for our intermediate product. The starting material is 5-methylhex-2-enoic acid. It has a resonance form that makes this oxygen from the C-double-O bond to have a negative formal charge. The oxygen on the alcohol group has a positive formal charge, and we're still in neutral conditions. To begin, the oxygen attacks the carbonyl carbon on the oxalyl chloride. Then the electrons push up to the oxygen and push back down, making chloride a leaving group. Chloride is a weak conjugate base. It deprotonates the alcohol to form an intermediate product that's shown on the left side of the screen. In the second step of the reaction, this intermediate reacts with 4-dimethylaminopyridine, DMAP, and oxazolidinone. DMAP is a derivative of pyridine. It's more basic and attacks the intermediate product at the carbonyl carbon. The electrons push up to the oxygen, and then it pushes back down, making this chloride a leaving group. Not shown in this drawing, The chloride is a weak conjugate base. It deprotonates the oxazolidinone present in the solution, and it deprotonates the hydrogen on the amide. There's still a positive charge on the nitrogen on our molecule. So now that the oxazolidinone is activated, guess what happens? The nitrogen attacks the C-double bond of that carbonyl, then it pushes up and down to push out DMAP, and then we form the second compound of our synthesis.
In the subsequent step, we synthesize the chiral compound to the next intermediate in one-step reaction with nitromethane and cesium carbonate. The literature found that great levels of antioselective results when product from this step was recrystallized with isopropyl alcohol. The electrons from the oxygen of the cesium carbonate attack the hydrogen to deprotonate the nitromethane. The electrons from the nitrogen then attack the alkene, which pushes the electrons up to the oxygen. The negatively charged electrons from the oxygen then push down, and the alkene will then grab a hydrogen to deprotonate the cesium carbonate. Even though they are not drawn, the cesium ions are present throughout this reaction. Using lithium hydroxide and hydrogen peroxide, the next intermediate compound was formed in a moderate diastereomeric excess via Michael addition of nitromethane to the Michael acceptor. The electrons from oxygen of the hydroxide from the lithium hydroxide deprotonates the hydrogen from the hydrogen peroxide. The electrons then from the oxygen attack the carbonyl of the intermediate, which then pushes the electrons towards the oxygen. The negatively charged electrons then push down and kick off the leaving group. Oxazolidone then gets protonated by water, while the oxygen on the lithium hydroxide attacks the carbonyl, which then pushes the electrons up towards the oxygen. The negatively charged electrons then kick down, which takes off the peroxide leaving group.
Moving on to the fourth step. Once the nitrate is synthesized onto the compound, what follows is a reduction of the nitro group with palladium on carbon under hydrogen gas. This is a 13-step mechanism, and we will not go over it for the sake of time, but we get our final product, and that's how you get Pregabalin or Lyrica.
Thank you.